Hello everyone, welcome to our webinar today. So the title of our webinar is Advanced Design and Advanced Steel Workflow for Steel Structures. My name is Farshad Pourshargh. I am the Senior Technical Manager at GRAITEC. I am taking care of our simulate software like Advanced Design at GRAITEC. So let's move on with our slides. Okay, so what we are going to be discussing today in this webinar, as you see here, we will show you the potential of using advanced design on how to design and code check your advanced steel projects. Then we will talk about the finite element analysis of advanced design and how you can benefit from that type of analysis to evaluate basically your structural behavior and design. We will talk about our beam workflow between advanced design and advanced steel. We will have a demo in the software, so I will show you how exactly the beam workflow is working, and finally we will have a conclusion. Okay, so let's talk about some of the main benefits of advanced design in case of steel structures and for especially advanced steel users. First of all, it's the beam workflow. So as you see here in this screenshot, we have a beam option that you can import, export, or even synchronize your projects between advanced steel and advanced design. So that is going to help you just to save some time because your engineer will not need to create the geometry again in advanced design. As well, we have some other benefits, like for example, all of the steel sections and material will be mapped automatically when you're doing this transfer. Then, if you change something in advanced steel or advanced design, let's say due to design considerations, we have the synchronization option that you can actually use it. It can be used in multiple elements. It's very fast to just find out what's been changed in advanced steel or advanced design. Maybe you have changed the column, either geometry or section, and synchronize it back to the source software. The beam workflow here, which is a GTCX beam workflow, it will also transfer all of the supports, like foundations. If you have defined in advanced steel model, you will have them as structure supports in advanced design. It can cover different types of sections. Other properties like geometry properties of elements like rotation, eccentricity, offset to from the analytical model will be also transferred through the beam transfer mechanism. And finally, just to let you know, in advanced design, we do not have you don't need to define nodes or etc. So we can just click and draw our elements and objects, columns, etc. So it's also very easy to modify your input model or add some extra elements to the input model. So if I want to talk about advanced design a bit, software itself. So as you see here, the first one is like the UI of advanced design is very similar to Autodesk products, like let's say like Revit. So here, as you see, we have a project browser that you can organize your model based on its geometry or properties, etc. That's gonna make it very easy for you to organize the model, delete some properties or modify them, etc. You can have subsystems in all of those. So for example, here I have a roof bracing, but inside that I can create another subsystem, which can be based on my sections or braces or geometry of the specific braces that I'm using. In terms of modeling, yeah, you have the option to either create your model manually, because in Advanced Designs UI you can create your own model. We have tools to create your geometry. Beside that, we also have structure generator. So here I've put like some of the examples here that if you want to use them, you will be able to create the geometry of structure automatically inside Advanced Design. And in case if you want to create it in Advanced Design, you can also send it back to Advanced Steel. So there are some differences, like if you want to talk about like Advanced Design and other competitors. So first thing is like we have a very good optimization engine in Advanced Design. So software will automatically provide you the most economic section that you can use for that member. Okay, so for example, if your member is overstressed or you have a higher workload ratio, Advanced Design will let you know that this member is not enough. You need to change it, probably a stronger section. But also the optimization would work too. So if, let's say, your workload ratio is smaller than a specific percentage, let's say 50%, which is adjustable in Advanced Design, software can offer you a more economic section. So that's what we call optimization. We also have the light gauge steel design based on the latest codes, ASI code added to Advanced Design that you can use. We have the full sections and materials that you can use based on North American codes. And the other thing is like in our linear elements, as you see here, we have an extra degree of freedom, which is a seventh degree of freedom in the rigidity matrix, which is basically considers the warping effect of the elements, in case if you want to consider that in your analysis. So load combination generator, very important. So as you may know, creating like loads like snow or wind and even seismic can be very difficult if you want to apply them manually. Again, in Advanced Design, you can apply them manually, but we can also use our automatic load generators. As you see here, we have climatic generators. So it can have like various geometry types, and also it can create like full loads, like even snowdrift, as you see here, triangular distribution. Advanced Design is able to create even that kind of very complicated loads on your structure automatically, so you don't need to actually manually define those. Same thing for the seismic analysis or seismic load generator. So we have different types of analysis. So we have the spectral, we have the modal analysis, we have time history analysis, and even if you want, we have pushover analysis in Advanced Design. So the other important part is basically when you are done with your design, you will need to have a report, a full report with detailed numbers and clause numbers of the code that we are using. So in Advanced Design, we provide you with those reports, and as well, those reports and tables are modifiable. So you can modify them and customize them, even filter some elements in case you want to see some specific report or formulas and results for your project. And finally, beside our main beam link that, as you know, like GTCX, which we will go into more detail shortly, Advanced Design also can talk based on other typical file formats. So you see some of them here, IFC, SCNF, and etc., even DXF, that if you have a project in DXF format, you can import it in Advanced Design. So codes are very important. So as you see here, I have put some screenshots here. This is for North American codes, basically US and Canada. And as you see, we cover like loadings, load combinations, climatic, reinforced concrete, steel, timber that you can switch. We also have the older versions, and we are always up to date. So we have a major release per year, and also several updates, following updates every year to keep the software up to date. And as you see here, we have thousands of satisfied users. So here it's like a general slide just to show you how complicated structures like you can create in Advanced Design, or even like send them from Advanced Steel. So these are like some of the projects that we have received from our clients, and in most of them actually they have used the beam workflow to import the steel structure from Advanced Steel inside Advanced Design and perform the analysis. Let's say the deformation you can see here that it's happening in the structure. Okay, if you want to focus a bit more on the beam workflow, so if you check out this graph here, so the first thing is we are using the GTCX format. This is the format of the file that it's been developed by GRAITEC, and the main difference here is either talking like about Advanced Steel or even Revit. If you're bringing a model, it can bring more detail inside your software. It can transfer more details. Like let's say you can have your internal forces transferred, you can have the rebar areas transferred, and etc. So this is the main difference of the GTCX format with other formats, and also it's gonna make us enable us to basically use also the synchronization tool, as I discussed later, as I will show you shortly, which is going to be through a GTCX format. That's one thing. The other thing is, as you see, the workflow is flexible. So you can start from Advanced Steel and through GTCX, send your model to Advanced Design, perform your analysis, do your code check, and again, you can send it back to Advanced Steel. That's one workflow. But the other one is also possible. So probably, let's say, an engineer wants to start from Advanced Design directly. That also would work, because as I mentioned, we have a UI in Advanced Design. You can create the geometry there, and after you can just export it through GTCX inside Advanced Steel. So the workflow is very flexible. And here also I have a screenshot of our synchronization window. So basically, as you see here, the synchronization tool will automatically detect all of the changes that you have applied in the model, and you will have the option to accept them or ignore them and apply them into your Advanced Steel model. So the other benefits of the beam workflow, again, it can also work on mixed structures. That's one thing. The other thing is like you should have a proper model when you're sending your geometry inside Advanced Design. And actually, this is correct for any structure software. So you should have your analytical lines correctly connected in nodes, so loads can be transferred. So if that's the case and you have some problems, in Advanced Design, we have a check and control tool that you can check if something like that is happening, if there's an instability, if there's a discontinuity in the model, you can check. And also we have tools to fix that. So we can stretch the elements to a node, we can offset them, trim them, extend them, etc. Which, as you see here in our tools menu in Advanced Design. And also very important here, as I mentioned earlier, the GTCX format is also able to export forces. So if you define those check marks there, you will have internal forces transferred to the target software. Okay, so let's go on and check this workflow and see how we can use actually Advanced Design to perform this beam workflow, and as well check our structural design in the software. So I have a model here. It's a steel model with foundations and slabs. And different types of sections, as you see here, like I have W sections, bracings, etc. So to send this model in GRAITEC Advanced Design, we can always go to our Power Pack here, and here you see three options. So we will be using the synchronization later on, but now I'm going to use export. So you click on export. And now what we can do is we can just save our file as a GTCX format. So in this case, for example, I can name my GTCX format as, let's say, AS to AD. So we are using the GTCX format, which is a GRAITEC format, and click Save. So yes. So now it's exported, and I'm gonna click on OK. So now we can open Advanced Design to import this file inside Advanced Design. So I have opened Advanced Design. This is the first page of the software, which is a structure analysis and design software. So just to let you know, you can have different code setup to basically verify your structure under different country codes. So for example, for North America, we have all of the Canadian codes, and as well for US, as you see, we have all of the codes that you can design your structure. So it has like the combinations, ASCE, seismic, climatic, reinforced concrete, steel, timber, as you see there. So for this demonstration, I can keep it as a US localization and click OK. And now very simple, I can click on beam import. Okay, I have opened the folder that I already saved my GTCX file. So this is the file AS2AD. You click there and click open. Okay, as you see, the structure is imported. So here you can have some project properties, name and address. I will just ignore it for now. And if we check the structure in 3D, we will see that it is the exactly same structure that we had in Advanced Steel. So I will just remove my work plane, and actually this structure is ready to run, so I can directly run my analysis. So in Advanced Design, we have like several ways of also modifying our model. So if you want to add elements or remove elements, or let's say check the properties of your columns or members, you can just click on them and all of the properties will be shown here. So you can have the material, you can have the section, etc., and also structure properties. And also we have other tools here to add like beams, columns, slabs, different supports, loads, and etc. So in this case, just to keep it short, I will just apply some dead load on this structure, which is from here. As you see, we have different types of loads. So we have dead loads, live loads. We have automatically generated climatic loads like snow and wind, as well as seismic and other types of loads. So you click on dead load and click OK. So it's going to automatically consider the self-weight of the structure. And if you want to add some extra loads, that is okay. So for example, I can just go here and just click on, let's say, linear loads or planar loads. And I can put my intensity here, say -50, for example. And we can just add our loads by just clicking on the roof element. Okay. So this is how easy it is to use Advanced Design. Now, because we want to do a steel design, I will just click and create my load combinations. We have an automatic load combination generator that you can use. And here, as you see, it's going to create all of the possible load combinations with the factors. I will click OK. And now we can run the analysis on this model. So steel calculation and click OK. Okay, so analysis is done. Actually, the first type of result that I see is going to be finite element results. Like I can see my deformation of the structure here. It's a full 3D rendered color map. I can check also, let's say, my internal forces, let's say axial force in columns. Okay, you can also activate the values on diagrams, etc., etc. So these are like some finite element results, and as well I can have access to my steel code check just to see if that section is passing the code check or no. So we can go with max work load ratio, and for strengths we also have the deflection option. So let's go strengths, click there. So here, as you see, I can see clearly which members are passing and which are not. So in this case, all of them are under 100%. So we are fine for this structure. So as you see, this is very simple. If you want to see, okay, what is happening for this beam, okay, why the load ratio is the value that is displayed here, you can select it. And here in our reports, you can also go more into detail. Like you will see all of the formulas and calculation behind that workload ratio, as you see there. So now I'm also going to show you how to send back this model inside Advanced Design with synchronization. Okay, so you have two options here. You can send your model, this model, directly inside a new model, or you can synchronize it back with the same model that you had before with the changes. So to just make it more interesting here, I can go on and let's say change the section of this column to something else. So let's say here I have W8 by 31. So I can just go to AD's library of sections, and from my ASCW sections, for example, we can select 519, okay? And click there, and that is gonna be assigned to this column as you see there. So let's imagine for any reason, let's say design results, design problems, etc. You had to change this column from 831 to 519. Now we are sending this model back inside Advanced Steel and just want to see if this change will be also applied to my Advanced Steel model. So to send it back, it's very simple. You go to Beam in Advanced Design, and here I can go and export this model back into Advanced Steel. You click there. So in the same folder, what I can do, I can save it as another name. Maybe we can call it this time AD to AS, okay? And it's going to be same format GTCX, and click Save. Okay, now we can go back into Advanced Steel and use our synchronization tool to call back this model in. So I will go to Advanced Steel. So as I mentioned earlier, you go to this tab here, and we're going to use synchronization. Click on that. Okay, this is the synchronization window, and we need to open the file that we just exported from Advanced Design. Okay, good. And if you remember, the file name was AD to AS. So we click on that and open. So as you see in synchronization window, we can see all of the list of subjects, etc. And as well, what is changed here. So it's going to be true in the list that you see here. We have search options here. You can search for material and type. So, and as you see here, it's already detected our changes here. You can even open it up, and you will see that it was an 831 before, and now it is a 519 section. Okay, and if you want to apply this to your Advanced Steel model, you can just click Accept. Okay, apply. Yes. We do not need a report. You click No. And now it's applying your changes to that section. I will click OK. And now let's go and see what is the section here in Advanced Steel. So yeah, as you see here, the section has been changed to 519. As before, it was the original section, so all of the columns had the 831 section. Okay, so let's go back to our slides. So just to conclude the webinar here, what are the main benefits of using this workflow and using Advanced Design for steel structures? As you see here, the first one is the beam workflow, automatic climatic load generators. Advanced Design is very user-friendly in case if you want to modify your model, change, switch stuff. We have the optimization option, light gauge steel design, full library of hot rolled or cold form sections and materials. You can customize your design reports. We cover all the international codes, like most of them. And we are working on the software to enhance it every year with code updates, new features, new tools, listening to our users. Then just to remind you about the beam workflow. So you can exchange the data in both directions. So it's a bi-directional link between Advanced Steel and Advanced Design. And as well, we have the same link with Autodesk Revit. So if you're doing a steel structure in Autodesk Revit, the workflow is very similar. So obviously, it's going to save cost and money, and also it's going to save cost and time in your daily projects because you don't need to create the geometry in each software, and the interface is very user-friendly and very efficient. And as you see here, the synchronization process will also help you in case if you have made some changes in your model. So just to answer this question, like for steel projects, which solution you can use both actually. You can use Advanced Steel or Advanced Design. Let's say in terms of creating drawings or fabrication drawings, detailing, you can use Advanced Steel. But if you want to code check the structure, apply the loads, check finite element results, etc., you can use Advanced Design. And as you see here, the other benefit is that you just need to create the geometry just once, and after that you can use the beam workflow to transfer your models from one software to the other one. Okay, thank you very much for your time and attending this webinar. So in case if you have a question or you want to give it a try and try the workflow and advanced design, don't hesitate to send us emails. As you see, our technical support email is support.us@graitec.com and support.canada@graitec.com. So let's go through some questions. So if you have any questions regarding the subject, please type them in the chat window of the platform, and I will answer them. Thank you.